Okay, so hi guys. So this is gonna be the intro for my CAS Project Dev Log. Some things sounds so stupid. Okay, so I didn't really talk about my earlier attempts, like my earlier attempts of this CAS project, which was which happened in like grade 11. I basically started this in grade 11, and I've changed this whole plan massively. So the code that I'm showing you right now, it uses Dijkstra's, I don't know how to pronounce it, Dijkstra's algorithm to find like the shortest path between nodes, and it basically uses a matrix, you know what I'm saying? So specifically, it employs a greedy approach, known as the nearest neighbor heuristic. So first, it finds the shortest path from the starting point to the nearest destination. Then it moves to that destination and repeats the process, finding the nearest remaining destination. It continues this until all destinations are visited. Finally, it calculates the path from the last destination to the checkout. And yeah, that's basically how the code works. And obviously, this code doesn't really account for any like obstacles or like anything else, really. It doesn't really account for like the layout of like the map or anything. It's basically just a matrix, like a, yeah. Okay, so this is the actual first attempt of this CAS project. So I basically just reinvented the whole thing. I carried the logic of like looking at the neighbors, what's the best option, logic from like my previous the previous versions of my code from grade 11, and I basically added in more logic for like the perimeter, the obstacles, and also I also added a start to end position for the algorithm.
This is my first test of my path planner for my CAS project. Alright, so here I've made like this map, and the red squares are like the obstacles that the algorithm has to avoid. So it's basically going to try to find the shortest path to cover every single tile in this obstacle course. And yeah, so this could be applied to robotics and agriculture, such as like drones. Okay, so there. So it's currently finding the path, and it could overlap through stuff, which is kind of, yeah. Whoa. Okay. Bro, this is not the shortest path, bro. Okay. Yeah, so that's the first test. 400. It took 451 steps. Okay. Bye, guys.
Hey guys, I made another thing. Yeah. I was planning to like model this. I was planning to model this for my local Mega Mart, but I'm like kind of lazy. Okay, so it's doing stuff. Okay. Okay. It's overlapping a lot. I noticed that. Okay, so it took around how much steps? How much steps? It took around 271 steps to complete this obstacle. Yeah. Alright, let's test if the replay works. Okay, it does. It does work.
Well, I have to like run the footage back to see if it actually works or not, but I could have sworn that was different. I could have sworn that was different. Wait, let's replay it again. Let's replay it again. Bro, I could have sworn it was freaking different, bro. There was something different about it. No, I think it's I think it's the same. Uh okay. Hey guys. I'm currently 635 lines deep into this code, and and shortly after the second devlog, I I realized the reason why it's not why the algorithm is not returning better solutions or like better routes or different routes is because I didn't code like functions for it. I didn't code like it's basically just static. It isn't improving on itself basically. This means that I need to probably stay up all night and probably change the whole algorithm. And the algorithm that I'm planning to use as substitute is the ant colony optimization algorithm. And I'm actually working on a time crunch here because on Saturday, actually record some field footage with my best friend Ken. 3 days I have to implement an ant colony optimization problem, like algorithm, into this. So yeah.